Question number 16. Question number 16 is option B. Option B. So because if you have a wide relation A is equals to a null relation, then definitely it will not be reflexive, but it is symmetric and transitive. So why it is symmetric and transitive? It will not be symmetric. It will not be symmetric if something like 1 comma 2 is there and 2 comma 1 is not there. Similarly, it is not transitive if 1 2 is there, 2 3 is there and 1 3 is not there. But definitely, so relation will not be reflexive, but it is symmetric and transitive. Therefore option B it is. 17th. So next one, number of reflexive relations of a set with 4 elements is equals to. So here we have one shortcut to find this. So it will be 2 raised to 4. It will be 2 raised to 4. If 4 elements are there, then 2 raised to 4 reflexive relations will be there. Okay. You can check this. So you can find 2, 4, 8, 16 different reflexive relations. This question number 18. So question number 18 will be question number 18. Modulus of a minus a, definitely it is 0, so less than or equals to 1. If modulus of a minus b is less than or equals to 1, then b minus a will also less than or equals to 1. But it is not transitive. Okay. So because modulus of a minus b less than or equals to 1 and modulus of b minus c less than or equals to 1 is not necessarily intent modulus of a minus c is less than or equals to 1. Therefore, it is option A. Next question number 19. Equivalence relation, the maximum number of equivalence relation on set A is equals to 1, 2, 3. Equivalence means it should be reflexive, symmetric as well as transitive. Okay. Suppose if the relation is R is equals to 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 3, 3, then definitely it is reflexive, symmetric and transitive. So you are giving the answer as 1. But no, it is not necessarily this one itself. So it will be with this 1, 1, 2, 2, 3, 3. I may have 1, 2 and 2, 1. I may have 1, 2 and 2, 1. Then also it will be equivalence relation because it is reflexive, symmetric, transitive, and R is equals to this 1, 1, 2, 2, 3, 3 is same. Okay, so this is same. Then I will consider 1, 3 and 3, 1. 1, 3 and 3, 1. Okay, so then also it is a reflexive. So already we have 1, 2, 3. So next I will consider R is equals to. So all these are same. Next 2, 3, 3, 2. One more is possible. Okay, so 2, 3, 3, 2. Then in CET, I will not going to find the fifth one because you don't have the option 4 or 5. You only have 1, 2, 3, 5, and you don't have none of these also. Therefore, definitely it will be 5. Definitely it will be 5, but I don't waste the time to find the fifth one So I can find this 1 2 2 1 1 3 3 1 2 3 3 2. So I can find that relation, but I will not waste that time. Therefore, the options plays an important role. Immediately by looking at the options, already we have exceeded 1 2 3. So if you got fourth one, then immediately option will be D, fifth. Okay, sorry, 5. You can find 5 equivalence relations, maximum 5. Next one, x square is equals to x into y is a relation which is yes, definitely it is reflexive because x into x will give you x square. So here I will explain after getting this as reflexive. So definitely you can say option B, but still, so while explaining it to you, so I will consider this problem in detail. So why it is not symmetric? If x into y is x square, what will be y into x is? Y into x will be y square. Therefore, it is not a symmetric. So why it is not a transitive? If x into y is equals to x square, then y into x is equals to y square. Then it will be x into x is equals to x square itself. Even you can consider, sorry, here you can consider y into z, okay? So y into z, then x into z will be x square. So what is the condition? If x comma y belongs to R, y comma z belongs to R, x comma z should be belongs to R, but that condition is not satisfying here. Therefore, it is reflexive. Next question number 21. The function f of x, sorry, f from R to R given by f of x is equals to x square for all x belongs to R is. You have different options. No, it is not option B. No. So here it is option D. Here it is option D, but very carefully listen to the explanation of this problem. Okay, so I'm going to explain this problem in three different techniques. So the first technique is f of x1. In fact, I will explain it in four different techniques. F of x1 is equals to f of x2. Then x1 square is equals to x2 square. So x1 is equals to plus or minus x2. Not only x1 is equals to x2, but x1 is equals to plus or minus x2. Therefore, not 1, 1. Not 1, 1. So second method is y is equals to f of x onto method. Okay, this is first method. I will explain this problem in four different methods. All the methods are useful in some problems, but for this problem I will explain all four different techniques. Y is equals to x square implies x is equals to root y. So if y is equals to, here this function is defined from r to r. If y is equals to minus 2, x is equals to square root of minus 2 does not belongs to r. X is equals to square root of minus 2 does not belongs to r. Okay, therefore it is not onto, hence it is option D. This is first method. So let me move into second method. Second method is graphical method. Second method is graphical method, or I will consider arrow diagram method. Arrow diagram method. Okay, so here r, in between it is x square. In between it is x square. So you have 0, 1, 2, or even any real number. Okay, minus 1, minus 2. Now here also it is 0, 1 by 2, 1, anything. Okay, so now 0 connects to 0, minus 1 and, so here it is 1. Okay, here it is 1, minus 1 and plus 1 both connects to 1, therefore it is not 1, 1. And even here the range is, codomain is r, but all elements are associating with only r plus. Range is r plus. So negative numbers are not having any pre-images, therefore it is not 1, 1 and onto. This is second method. Third method is graphical method. Third method is a graph method. So what you need to do, you need to draw graph of this function. Y is equals to x square means it is just like this. Okay, you need to draw a line parallel to x-axis. Line parallel to x-axis. If it cuts the graph at more than one point, definitely it is not 1, 1. Definitely it is not 1, 1. Okay, so here if you draw a line parallel to x-axis, then it cuts at more than one point, therefore it is not 1, 1. And for onto, you need to look at for what values of y this function is lying. So see here, this function, the graph is lying above x-axis only. So below x-axis, these values are blank. The graph is not at all here. Therefore, for y, you are only getting positive values. First and second quadrant, y is either positive or 0. Therefore, here codomain not equals to range. See here, if the graph was like this, it is covering both positive and negative values of y. The negative values in third quadrant, positive values in first quadrant. Therefore, it may have onto function. But here, graph is only covering positive values. Therefore, it is not onto. See here, to identify whether it is 1, 1 and not 1, 1 or not, you need to draw a line parallel to x-axis. If it cuts at more than one point, definitely it is not 1, 1. Then to identify whether it is onto or not, you need to check where the graph is lying. Whether it is covering all codomain values, then it is onto, otherwise it is not onto. So this is third method. And fourth method. Fourth method is a derivative method. It is useful for only finding it is 1, 1 or not. Fourth method is a derivative method. If f of x is given, you need to find f dash of x. If f of x is given, you need to find f dash of x. If f dash of x is greater than 0, if f dash of x is greater than 0 throughout, then it is 1 1. Then it is 1 1. Not necessarily this, or f dash of x is less than for all x, okay? For all x belongs to domain. For all x belongs to domain. This concept will be understanding those who knows the derivatives. In first PU itself, you know how to find derivative of a function. If f dash of x is less than 0, then also it is 1 1. Then also it is 1 1. It should be for all x belongs to domain. If it is greater than f dash of x is greater than 0 for some values, f dash of x is less than 0 for some values, then definitely it is not 1 1. Definitely it is not a 1 1. So okay, here I will show how. So f dash of x is greater than 0 means what? In application of derivative chapter, we have studied if f dash of x is greater than 0, then the graph is strictly increasing. The graph is strictly increasing. It may be like this. It may be like this. If the graph is strictly increasing, if you draw lines parallel to x-axis, it will not cut at more than 1 points. It will not cut at more than 1 points. More than 1 point. Therefore, it is 1 1. And even if it is f dash of x is less than 0, f dash of x is less than 0, means the graph is strictly decreasing. The graph is strictly decreasing. In this case also, a line parallel to x-axis, we call it as horizontal line. The line parallel to x-axis, we call it as horizontal line. If you draw horizontal line, it will not cut at more than 1 point. Therefore, definitely it will be 1 1 function. Okay. So this idea will initiate a very useful shortcut. Okay, so now let me come back to this problem. Okay, so this problem, neither 1 1 nor on 2, either you can use this graphical method. So otherwise, derivative method, calculus method, we call it as calculus method. F dash of x is equals to what? So in first PU, we have differentiated x square, which is equals to 2x. Derivative of x square is 2x. Therefore, you cannot say it is greater than 0 or you cannot say it is less than 0. It depends on x. It depends on x. Therefore, it is neither, it is not 1 1. It is not 1 1. Okay. So here itself, I will give you few more questions. Few more questions. F of x is equals to x cube from R to R. F is from R to R for every question. Okay. F is from R to R. So whether it is 1 1 or not, f from R to R. So already I have mentioned few methods. You can use any method. I will consider f dash of x. I will consider f dash of x, which is equals to 3x square. Since it contains x square terms, I can say this is greater than 0 for all x. For all x belongs to R, I can say it is greater than 0 for all x belongs to R. Therefore, it is 1 1. Therefore, it is 1 1. Therefore, it is 1 1. Next, I will give f of x is equals to x raised to 4. All functions are defined from R to R. All these functions are defined from R to R. F of x is equals to x raised to 4. Then f dash of x is equals to 4x cube. 4x cube. Therefore, it is not 1 1 because it depends on x. If x is positive, 4x cube is positive. If x is negative, 4x cube is negative. But if it is 3x square, whatever may be x value, positive or negative, no problem. It is always greater than 0. So next I will give f of x is equals to minus x raised to 5 or minus x cube itself. Minus x cube. Then also it is 1 1 because it will be minus 3x square. Minus 3x square, which is less than 0. We should get either greater than 0 or less than 0. Then it is 1 1. This is one important hint. And one more important hint regarding this 1 1 and onto function is if the function is defined from R to R, if f is defined from R to R, if f is defined from R to R, every odd power of x, odd power of, if the power of x is odd power of x, then it is onto, then it is onto even power, then not onto. Therefore, x square, x raised to 4, x raised to 6, all these functions from R to R will not be onto functions. But x cube, x raised to 5, all these functions will be onto functions from R to R. So now I will consider a JEE question. A function f from R to R, a function f from R to R given by f of x is equals to, f of x is equals to x cube plus x. X cube plus x is option only 1 1, only 1 1, only onto 1 1, but not onto fourth option bijective. Better you consider the options as A, B, C, D. A, B, C, D. So this function, we have many shortcuts. Either you can draw the graph or you can go for calculus method. So anything. So let me find f dash of x first to identify whether it is 1 1 or not. 1 1 or not. Okay. So it is 3x square plus 1. 3x square plus 1. Whatever may be the value of x, it is clearly greater than 0. It is clearly greater than 0. Therefore, it is 1 1. It is 1 1. And one more hint I have given is, if the function is odd powers of x, if the function is odd powers of x, and if it is from R to R, definitely it is onto. I said definitely it is onto. Therefore, this is 1 1 as well as onto. Hence, it is bijective. If you don't know the shortcuts like this, if you go for x1 cube plus x1 is equals to x2 cube plus x2, then you cannot solve this problem very easily. You should know these simplest methods to solve JEE problems. Okay, so let us move into next problem. Problem number 22. The function f from R to R defined by f of x is equals to x minus 1 into x minus 2 into x minus 3 is. So for this problem, drawing graph or finding derivative, both are not easy process. Therefore I will go for another method. So here it is from R to R. Therefore I can give 0, 1, 2, 3 these values. Okay, if I give input as 1, what will be output? 1 connects to 0. 2, if I give input 2, output will be 0. If I give input 3, output will be 0. Therefore clearly it is not 1 1, not 1 1, not 1 1. But if you multiply this, f of x is equals to x minus 1 into x minus 2 into x minus 3. If you multiply this, then it will be, highest term will be x cube. Highest term will be x cube. Therefore, since it is odd and it is from R to R, it will be on to, but not 1 1. It will be on to, but not 1 1. Next problem. Yes, it is a C. Okay, so we have the formula NPM. NPM means 4P3, which is equals to 4 into 3 into 2. So is equals to this. Therefore, synopsis plays an important role in solving the problems. Okay, so you should be very careful with the synopsis. That's why before the day, so yesterday only, I have sent the synopsis. Even I have explained this. So D or B, no. So we don't have options like D or B. Okay, you should be specify with your answer. D or B, like no. A or B or C or D will be answer for every question in CET. You can say like that also. A or B or C or D. That will be excellent answer, it seems, for every question from question number 1 to 60. If you write like A or B or C or D, then definitely your CET marks will be highest than any other student if you come from the backside. I hope you understand what I said. Next question. The function f from R to R defined by f of x is equals to e raised to x is. If you know the graph of exponential function y is equals to e raised to x, this problem can be solved in 5 seconds. Okay, so e raised to x, f of x is equals to e raised to x. This is the graph of the function y is equals to e raised to x. Okay, so log x and e raised to x functions are studied in calculus. Y is equals to e raised to x. The function f is defined from r to r. I hope now you can say clearly it is 1 1, but not onto, because graph is not lying in negative part of y, only it is lying above x-axis, means y is positive, but since f is from r to r, this r contains negative value also. Therefore codomain will not be equals to range, hence it will be 1 1 and into. A function which is not onto is called as into. A function which is not 1 1 is called as many 1. So it is a 2002 Karnataka CET problem. If you know the shortcuts like this, you can solve the problem very easily. Next problem. So it's a problem of AIEEE 2003. AIEEE means nowadays it is called as JEE mains. To get the seats in NITs. Those days AIEEE was the examination, but now JEE mains. A function f from the set of natural numbers to integers defined by f of n is equals to n minus 1 by 2 when n is odd and minus n by 2 when n is even is. So here the definition is splitted. Therefore, for these splitted definition problems, it's better to draw this arrow diagram. So the function is defined from a function f from the set of natural numbers to integers. Natural numbers to integers. So here it is 1, 2, 3, 4, 5, 6 enough. So from these values we can identify whether it is 1, 1 and onto or not. Okay. So we can imagine, not identify. We can get the idea like this. 1, 2, 3. So now, if you give the input as 1, 1 is even. Therefore, if it is even, it is minus n by 2. Okay. So if the number is, sorry, 1 is odd. Okay. Sorry, 1 is odd. If the number is odd, then n minus 1 by 2. If you give input 1, 1 minus 1 by 2. So it connects to 0. This 1 connects to 0. Then if you consider 2, then 2 by 2 minus 1. 2 connects to minus 1. Next, if you consider 3, 3 will be connected to. 3 is odd. So 3 minus 1 by 2. 2 by 2, it connects to plus 1. 3 connects to plus 1. 4. 4 connects to minus 2. 4 connects to minus 2. Next, 5. 5 connects to 5 minus 1, 4 by 2, 2. Okay. So 6 connects to minus 3. Therefore, you can clearly see it is 1, 1 as well as onto. It is 1, 1 as well as onto. Okay. So question number 25 will be option C. Both 1, 1 and onto it will be. Both 1, 1 and onto. So next, try question number 26, 27, 28 as homework. Okay, question number 26, 27, 28 as homework, and remaining problems will be considered in next class.